Hello everyone. In today's session, we again solve one example on Booth's algorithm. But the difference between this and previous example is, in previous example we just represent our multiplicand and multiplier in 3 bits because number was 5 and we required only 3 bits to represent that in binary form. Let's solve one example with number which require 4 bits to represent in binary. And this example is again from that same case where your multiplicand is negative and multiplier is positive. So in this example, we are considering multiplicand as a minus 13 and multiplier as a plus 11. In last session, I already given this example to practice it, and I hope you got answer as 143, which is minus. And if you are not getting, then let's solve here, and you can observe where you stuck in last homework. So let's start with first step where we need to represent these 13 in binary form. We require 4 bits, that will be 1 1 0 1. Yes, so is that sufficient? Yeah, if your answer is no, then you are right. It's not sufficient. Why? Because we required one more bit here at MSB which will represent the sign of this number. And here in this case, as 13 is positive, first we are considering positive 13. So as our 13 is positive, we should consider 0 as a sign bit. So now let's take 1's complement of this number, and it should be 1 0 0 1 0. And now when we take 2's complement of this number, we get negation of original number, and which is 13 here. So for 2's complement, we should add 1 here. Then your number will be 1 0 0 1 1, and which is nothing but minus 13. Okay. In last session also we followed same procedure, but I got one query from your side, that is that minus 30, and if it is yes, then how to prove that? So it is very simple. I already discussed that in first session where we studied recoded form of your original multiplier into Booth's multiplier. Let's check whether this is minus 13 or not. So for that, you know very well, weight of this number is 1, then it will be 2, 1 2 4 8, these are 0, so we don't need to consider that. So 1 2 4 8, and this will be 16. But as your MSB is sign bit, so we should consider this as a minus 16. So minus 16 plus 2 plus 1, so which is nothing but minus 13. Okay. We'll check our Booth's multiplier in the same way, and again we will verify whether that new form or recoded multiplier is same as your this multiplier or not. And 1 2 0 1. So our recoded multiplier is 1 minus 1, 1 0 minus 1. And now we will verify that this recoded multiplier is correct or not. So how to do that? Just write your recorded multiplier here, which is 1 minus 1 1 0 minus 1. Now you can check. This will be minus 1. How to write that? You know the weightage of each position is 1 2 4 8 and 60, right? So this will be minus 1, this will be 0, this will be 4, this will be minus 8, and this will be 16. And if you add that, this will be plus 8 plus 4 12, 12 minus 1 11. So you can check our multiplier is 11. So we are not changing our number. What we are doing, we are changing form. The 1 0 1 1 is also 11, and 1 minus 1 1 0 minus 1 is also 11. Okay, I will write this, and now we can multiply 1 0 0 1 1 by our recorded multiplier, which is 1 minus 1 1 0 minus 1. Now you know very well, as we discussed earlier, when we multiply our multiplicand by a minus 1, we have to take 2's complement of that. We already calculated our 2's complement for 1011, sorry 10011, and which is 10010. Yeah. Oh, sorry, not this. It should be this one. So 2's complement of 10011 is 0 1 1 0 1. Okay. Now if you remember, we have to extend our sign bit. Okay, so our sign bit is 0 and we have to extend till 2nth bit. Okay, if you remember, we have to extend sign bit till 2/9th bit. So we have 5 bits in multiplier and multiplicand, so we have to extend this up to 10th bit. So you can write more zeros here at MSB. Okay, now we have 10 bits in product. Again, follow same procedure and multiply this number by 0. Okay, this will remain 0. Then also just write to avoid any confusion. Yeah. Now you can multiply this number by 1, so that will be 1 1 0 0 1. And again, don't forget sign extension, so we have to extend this MSB, which is 1 till 2nth bit. Okay. Now again multiply multiplicand by minus 1, so that will be 1 0 1 1 0, and this will be 0 0. Again, last number, multiply this with 1, that number will remain same, which will be 1 1 0 0 1, and again we have to write 1. I will write this. Yeah. So we can add this. So at LSB there will be 1, this will be 0, so 1 1 0 and carry 1, so there are 4 1s, so we can write 0 and 2 carries here. So now here we have 3 1s, so we can write 1 and 1 carry, again 1 carry, again we have 3 1s, 1 carry, that will be 0, again 1, we have 3 1s, so we can write 1 1 1. So if you remember, in result also we have to consider up to 2nth bit only. Okay, so we'll discard this carry. Yeah, so this is our final answer. Again we'll check that answer whether we got correct or not. So we are expecting minus 143 here, so let's check. This will be 1 2 4 8 16 32 64 and 28 256 and minus 5 12. And why minus? Because this bit is sign bit, so if it is 1 we have to take minus, if it is 0 we have to take, okay, we don't require any number to write that if it is 0. Okay, so minus 512 plus 256 plus 64 plus 32 plus 16 plus 1. Yeah, this is nothing but what? Minus 143. So our answer is correct. Okay, in exam you don't need to write this. Yeah, this is sufficient. So if you have any query regarding Booth's algorithm, you can write in comment section, or you can directly message me. You have my number, and you can solve for a different number. This will be your homework. Already we solved for 5 multiplied by 5, where we consider your multiplicand as a negative 5 and multiplier as a positive 5. You can solve for different case where our multiplicand is positive and multiplier is negative. Okay, and in next session we will start with fast multiplication process, which is nothing but advanced Booth's algorithm. Thank you.